I'm Anil Kumar sharing with you questions on sine law and cosine law. We'll have about 11 multiple choice questions followed by 3 descriptive thinking application questions. The very first question here is identify correct choices. Consider an oblique triangle. Oblique triangle is a triangle which is not 90 degrees triangle. Consider an oblique triangle ABC with corresponding sides A, B and C for the following questions. So what we mean here is that we have to consider a triangle which is not a 90 degrees triangle, that is oblique triangle. So let me make one here, A, B and C. Sides opposite, that's a nomenclature. A will be A, B will be lowercase b and capital C will be. So vertices are always written by capital letters, sides opposite by lowercase. Question 1. You can use sine law for calculations if you know the measures of what? 6 choices are given. Question number 2 is you can use cosine law for calculations if you know the measures of what? And remember, you can have more than one choice in these questions. The idea is to understand the concept, and then we are going to use this concept to solve questions. So let's see. We are now looking for sine law and cosine law. The idea is that sine law you could always do if we are talking about any two angles and a side, or we are talking about two sides and the third angle, right? So we need one opposite angle side pair. That is what we need to use sine law. As far as the cosine law is concerned, we're looking for these combinations, side, side, side. Side, 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 or included angle. That means side, angle, side, right? Now let's answer. A, B, C are 3 sides. That should be good for cosine law. So I'm circling here. Second, A, B, that means sides A and B and angle C. So included angle. So this included angle goes for cosine law. C, B, angle C. C, B and angle C is the third angle. So we have this combination. Do you see that? We have this combination. So that goes for sine law. D, A, C and B. So all 3 are different. Do you see that? If all 3 are different, A, C and B, A, C and B, in that case, it is always cosine law. A, C and B. Do you see that? A, C and B. So it is included angle. It goes for cosine law. Then we have 2 angles and a side. Always you can use sine law. And then we have 3 angles. Now whenever we have 3 angles, then the triangle could be of any shape. These triangles are similar triangles, but they are not defined, right? So there could be many triangles with all same angles, correct? For example, I could have a triangle like this, I could have a triangle like this, or kind of like this. Do you see that? So the triangle is not really defined if you give all the 3 sides. So I hope that helps you to understand when to use sine law and cosine law. Well, if you have an option, you have to always go for sine law first. Is it okay? That's better. Now let's look into question number 3. That is, what is the minimum number of facts that you need to know to solve any triangle with sine or cosine law? So we have seen that we need 3 combinations. Could be 2 angles or a side, 2 sides of an angle. So the option is B, right? So I hope this part is absolutely clear. So we know when to use sine law and when to use cosine law. Now let's use sine law and cosine law to find or solve some triangles. How many triangles could be formed? That is the question now. Now we could have ambiguous cases. So let me just discuss that a bit and then we'll move forward on this. So let's say we have a triangle, and the triangle we are using ABC just to keep things very simple. That means we are now working on side A, B and C. Now how many triangles could be formed? A. If angle A is 30 degrees, so it is an acute angle, and side A is less than B, and side A is less than B. Now, if that is the case, we have to see what is the height, right? So given this angle, we have to see what height is. In this case, it is 30 degrees and B is 5. So we'll calculate the value B of sine 30 degrees and compare it with A. This is the height, correct? So let's use this value, calculate. So let me convert my calculator to degrees. Let's be sure about it. Okay. So we'll do 5 sine of 30 degrees, which is equal to 5 over 2 or 2.5. So height is 2.5 and we are given A is also 2.5. Now, which is also equals to A. That means we'll make a right triangle. Do you understand? So in this particular case, we'll actually make only one triangle, and this triangle is special. It will be a right triangle. So that is the concept. If A is greater, we'll get 2. If A is smaller, we won't get any triangle. Question 5. If angle A is 100, that is to say, now we are talking about an obtuse angle, right? So if it is an obtuse angle, side A has to be longest, correct? But what we are given here is that A is less than B. So that means no triangle, correct? Because A is the obtuse angle, so that is the longest side. That is supposed to be the longest. Since it is not, we cannot make a triangle. Question number 6. If angle A is 50, now in this case, what we have is angle A of 50. So let me just sketch one here, small triangle. Okay. So what we have here is angle A of 50 degrees, 5.5, 45 degrees. Now, whenever you're given two angles, then the third angle is also defined and one side is given. So we have a fixed one triangle case, right? So that is it. So it is going to be one triangle. Remember, ambiguous cases are only there when we are given two sides and an angle. So remember that ambiguous cases are only when we are given two sides and an angle, right? Otherwise, these are all fixed cases, no hanky-panky about it, correct? Question number 7. Angle is 70 degrees and we are given the sides. We are given two sides. Now in this particular case, let us sketch this. Okay. We are again given acute angle. So acute angle is 70 degrees and the sides are A 1.51, B is 1.59. So as we did in the first case, let us find what height is. So height is 1.59 times sine of angle 70, which is, let's write down, 1.59 times sine of 70 degrees, which is equals to 1.49. Now in this case, we see that A is greater than height and A is less than B. Therefore, we could actually have two triangles. So this is not the, so the position is kind of like this. Position is like this particular case. So we have two triangles. So that is how we can answer these cases which are based on ambiguous case. Now let's go to question number 8, which is determine measure of angle B to the nearest degree. So now we will solve the triangles. We are given obtuse angle. Okay, so we have given obtuse angle A. So let's just sketch a triangle now. A is 100 degrees. Side A is 9, B is 6. Let me call this point as B, and that becomes C. Now we have a combination of opposite angle and side, so we can use sine law. Perfect. So using sine law, we can find what is angle B. That is what we want to find. So we get sine B over the side opposite, which is 6, is equal to sine of 100 over 9. And that gives you sine B equals to, we could actually find what the angle is. Angle is sine inverse of 6 times sine 100 divided by 9, right? So let's calculate this. So we have shift sine inverse. Within brackets, we have 6 times sine of 100 degrees divided by 9. That gives you 41. So we get this angle as 41 degrees. 41 degrees is option C for us. So that is the right answer. Question 9. Determine measure of the side C to the nearest tenth of a unit. So this time we have to calculate the side. We are given 2 angles and 1 side. Okay, so let's sketch this. So we are given 2 angles and 1 side. One angle is, let's say, 70 degrees. The other one is 50 degrees. Okay. These diagrams are not to the scale, as you can see. I prefer to write A on the left side. Now this is 5 for us. The angle is 50 degrees. Now whenever you're given a situation like this, you know sum of the angles is always 180, right? So angle C equals to 180 minus 70 degrees minus 50 degrees, correct? So let's calculate this. We get 180 minus 70 minus 50 equals to 60 degrees. So that is 60 degrees. We need to find side C. So we can say C over sine of 60 degrees is equal to 5 over sine of 70 degrees. Correct? So this implies that C is equals to 5 times sine of 60 degrees divided by sine of 70 degrees. Correct? So let's calculate. So we have 5 times sine of 60 degrees divided by sine of 70 degrees. That is 4.6. So we get 4.6 as the answer. Option A is the right option. So let's move on to question number 10. Determine measure of angle B to the nearest degree. Question 10 is, if angle A is 45 degrees, B is 38.0 and C is 24.5. So let me sketch a triangle here and then we'll solve it. We are given 45 degrees as one angle. The other angles are not known to us. We know 2 sides. So the triangle here is ABC. Angle A is 45 degrees. Side B is 38.0. Side C is 24.5. So this is a case of SAS. So we are going to use cosine law. So when we have cases of SAS or SSS, we use cosine law. We need to find the angle. Okay. Now in this particular case, first we have to find the side opposite to A. Once we find that out, then using sine law, we can find angle B, right? So let us find the side A first. So A square is equal to square of these two, add them up, 38.0 square plus 24.5 square minus 2 times 38.0 times 24.5 times cos of 45 degrees, correct? So we can get the side A. So A is equals to, let's calculate this, we'll do square root of this. So we have 38 square plus 24.5 square minus 2 times 38 times 24.5 times cos of 45 degrees. And that gives you 727.62, let's say. So that is a square. So if I square root this, I get my answer for a. So square root of the answer is equal to 26.974, right? So that becomes the side A. Now, once I know side A, then I can actually find the angle, correct? So now we can apply the sine law. Now we know side A, right, which is approximately 27.0. Now we can use the sine law. So we get sine B over the opposite side of 38.0, and that is equals to sine of 45 degrees over A, which is 26 point, let's use 97, and then we get sine B as equals to 38 times sine of 45 degrees over 26.97. So we get 38 times sine of 45 degrees divided by 26.97. We have 0.99629. So angle B is equals to sine inverse of all this, 0.99629. So let's find sine inverse of this. Shift sine inverse of our answer is equal to 85.06. So we get 85.06 as our answer for this particular question. Now that is not a choice really. So let me write down E, which is 85 degrees as the correct answer. So there might be some typing error here. Now here is question number 11. You need to determine the measure of smallest angle if P equals to 5, Q equals to 6, and R equals to 7. We are talking about a triangle PQR. Okay, so just let me sketch one triangle and then we'll work it out. So we are given 5, 6, 7. 5, 6, 7 as the sides. So where P is opposite to 5, Q is this, and that is R. Correct. Now the smallest angle will be P in this case, since the side opposite to P is smallest. Is it okay? So let's find the angle P. Now we know that P square is equal to Q square plus R square minus 2 QR cos of angle P. We can rearrange this cosine law formula. So we get 2QR cos of P is equals to Q square plus R square minus P square. So cos of P is equals to Q square plus R square minus P square divided by 2QR, and therefore we can say we can say P is equals to cos inverse of Q square plus R square minus P square over 2QR. Now this is a standard formula which most of you know, but I just derived it for those who don't remember. So we get the angle P as equal to cos inverse of sum of these two squares which are adjacent, right? 7 square plus 6 square minus 5 square divided by twice 7 and 6. So this is easy to remember, right? So that is how you could do it. Let's calculate the answer. So we have cos inverse within brackets. Let's write 7 square plus 6 square minus 5 square. So that's the numerator. And we are going to divide this by, let's write in brackets, 2 times 7 times 6, 2 brackets close, equals to. So we get an angle of 44.4 degrees. So which rounds to 44 degrees, right? Which rounds to 44 degrees. So A is the right answer, correct? So we have taken up examples on sine law and cosine law. Now let us do question number 12, which is kind of descriptive. Question number 12 is, a plane is approaching 5.5 kilometer runway. The angles of depression at the end of the runway are 9 degree and 15 degrees. How far is the plane from each end of the runway? Now that's a application question. Let us say this is the runway, right? So the plane is approaching, let's say the angle which it makes with the two ends of the runway is, let's say like this kind of. Let us sketch like this. Okay. Now, angle of depression is always with the horizontal. So, one of these smaller angles is 9 degrees. So, we have 9 degrees, which is this much. And then we have 15 degrees, which is that much, 15 degrees. Let's say this is the far end. Let's say this is the close end AB. And let's say that is the point P for the plane. Now we are given the length of the runway as 5.5 kilometers. We need to find these two lengths, A to P and B to P. Now what you can do here is you can actually calculate. We need actually at least two angles and one side, correct, to solve this particular triangle. So we can get the angle BPA, BPA as equal to 15 degrees minus 9 degrees, correct? So which is 6 degrees. So that is 6 degrees angle here. We can also write down what the angle here is. Angle here will be 9 degrees, correct? 15 degrees. If you compare with this line, so it is 15 degrees here, and so angle BAP, the interior angle, will be 180 degrees minus 15 degrees, correct? So let's do it. 180 minus 15, that gives you 165 degrees. So first step is to calculate all the angles. Now we have one combination of opposite angles, and therefore we can apply sine law. Correct? Since we have this combination of opposite angle and a side, so it is side angle angle. We can find both these sides when compared with this angle. Now once we know two angles, we can also find the third angle. So let's find the third angle also, and then we'll do. So 180 minus 165 minus 6 gives us the third angle, which is 9 degrees. You could have done with alternate angles between parallel lines also. Now we know this ratio, which is 5.5 over sine of 6 degrees. That is equal to the ratio of AP over the angle opposite to AP. So AP angle opposite is 9 degrees. So we get sine of 9 degrees. And PB or BP, angle opposite to BP is 165 degrees. So sine of 165 degrees, correct? So let's figure it out. So we can find both now. AP is equals to 5.5 times sine of 9 degrees divided by sine of 6 degrees, and BP is equal to 5.5 times sine of 165 degrees divided by sine of 6 degrees. Okay? Let's calculate. So we have 5.5 times sine of 9 degrees divided by sine of 6. That gives us 8.23. And the other one is 5.5 times sine of 165 divided by sine of 6, and that is 13.61 kilometers, right? So the distances from the runways are, so we get our answer, that from the farther side it is 13.6, we can round it, 13.6 kilometers, and from the nearer side it is 8.2 kilometers, correct? So that is how we can answer. So I hope the steps are absolutely clear. It's a very good example based on sine law. Now let's move on to question number 13. Two ships are approaching a harbor. One ship is 4.8 miles from the harbor on a bearing of 35 degrees. The other ship is 8.2 miles away from the harbor on a bearing of 285 degrees. How far apart are the two ships? So let's sketch. So whenever we are talking about bearing angles, we are measuring from north, correct? So the first one is on the bearing of 35 degrees, that is from north 35 degrees. Let us say this much, somewhere here, right? So this is 4.8 miles and the angle here is 35 degrees. The other one is 8.2 miles away on a bearing of 285. So 285 is more than 270, so somewhere on this side, right? So that becomes 285. And this is 8.2 miles. So let's say this is point here, which is 8.2 miles. How far are they? So we have to basically find the distance between them. So this is the distance which we are looking for. So these are two ships A and B, let us say. And we have to find that length. Now we can always calculate the angle. Since it is 285, let's see. So let us calculate this angle. Let me call this point as O. So let's calculate that angle, which is 360 degrees. Take away 285. Right? So this gives you 360 minus 285 is equal to 75 degrees. So that angle is 75 degrees. So the angle BOA is equal to 75 degrees plus 35 degrees. So let's add 35 degrees to this, plus 35, 110 degrees. So the total angle here is 110 degrees. Now we know two sides with included angle. So therefore we apply cosine law. So AB square, the distance between the two boats or the ship R, is 8.2 square plus 4.8 square minus 2 times 8.2, 4.8 cos of 110 degrees. So let's calculate this. 8.2 square plus 4.8 square minus 2 times 8.2 times 4.8 times cos of 110 degrees is equal to 117.2. So AB will be equal to square root of this. So let's find square root of our answer, which is 10.826. So the answer is approximated to 10.8 miles. So we get 10.8 miles between A and B. So that is how you can answer it. Now let's move on to the last question of our set. I hope you are enjoying this journey and also learning how to apply sine law and cosine law. Question number 14. Part of a roof of a warehouse has a slope of 1/3 and the other part of the roof has a slope of 0.5, that is half. The width of the house is 30 meters. Find the height of the roof. So what we're given here is, let me just sketch here. Let's say this is a 30-meter long roof. Okay. So part of the roof has slope of 1/3, right? So let's say this angle is theta. We can find this angle theta. Tan theta equals to slope, which is 1/3, right? Rise over run, correct? Slope is rise over run, so that gives you tan theta. Now, so theta equals to tan inverse of 1/3. So it's important to understand what slope is. So what we are trying to say here is slope is, let me write down here. Slope equals to rise over run. So if that is my right triangle, if you look from here, this is the rise, the height, and that is the run. And we are given this ratio is 1:3, and therefore we can find theta. Right? So let's use inverse tan of 1 divided by 3 to get this angle, which is 18.434. So we'll write 18.435. Okay. So that gives you the angle theta. Now we are also given the slope of the other side. So let's say this angle is, let's say, phi. So we use tan phi as equals to half. So phi is tan inverse of half. Tan inverse of half is, or 0.5, is 26.565. 565. We are going to round later. Let us take these angles to 3 decimal places to begin with. Now we need to find the height of this, and what we know is that the total width is 30 meters. Now we have found these angles. We have the width. Now there are a couple of ways in which we could do it. One way, of course, is to find one of these sides, or we could find the angle on the top, right? Since we know these two angles, we can actually find the angle on the top, right? So let's find that angle and then use sine law to find one of these sides, right? So let me name this as A, B, and C. Then angle ACB will be 180 degrees. Take away 18.435, take away 26.565. So that gives you 180. Take away 18.435, take away 26.565 is equal to 135 degrees. So this angle is 135 degrees. Since we know this angle now, we can use sine law and find any one of these angles. So now we'll use sine law to find any of these angles. So let me use this space. Let us say we want to find AC. So AC over the angle opposite, which is angle B, will be sine of angle B is phi, 26.565 should be equal to 30 over sine of 135, correct? So AC is equals to 30 over sine of 135 degrees times sine of 26.565. So we'll find 30 times sine of 135 divided by, 30 times sine of 26.565 divided by sine of 135, which is equal to AC is 18.97. So we get AC as 18.97, right? Now once we know AC and when we know this angle theta, then we can find height. So this ratio relating height and hypotenuse is sine. So we can write sine theta, and theta is 18.435 is equal to height divided by AC, which is 18.97. So that gives you the height as equal to 18.97 times sine of 18.435, correct? So let's calculate this. We already have 18.97. We'll multiply by sine of 18.435. So that gives you a height of 6 units. So we get height of 6 and the units are meters. So our answer is height equals to 6 meters. So I hope you understand and appreciate how we solved this question. Slope basically is rise over run, and slope can be given by tan of the angle. Tan is rise over run, right? So we found these two angles. Once we knew two angles, we found the third angle using the fact that sum of triangles angles is 180 degrees. So when you take away the sum of other two, you get the third angle, which is 135 degrees for us. Now we calculated one of the sides of the roof using sine law and then applied trigonometric ratios in right triangle to calculate the height. So with that, we come to an end of our video on review of sine and cosine law. I hope you enjoyed this journey of learning from the very basics to application and thinking questions just as this one. Feel free to write your comments and share your views, and if you like and subscribe to my videos, that'd be great. Thank you and all the best.